All right, let's dive in. This is a story all about human ingenuity. It's this incredible journey, right? It starts with the absolute simplest tools we ever made, and it ends with something that sounds like it's straight out of science fiction, thinking matter.
No, really. Take a second. Really look around you. That desk you're at, the mug with your coffee, the screen you're staring at right now, all of it is made of stuff. And the story of how we got from, just shaping a stick to building electronics that can almost think for themselves, well, that's pretty much the story of us.
So, here's how we're going to break this down. We're going to start way back in the ancient past with the one material that you could say built civilizations. Then, we'll jump to the stuff that was forged in fire for our modern world. And finally, this is the really fun part. We're going to peek into a future that's being built from materials that can literally react and respond all on their own.
And yeah, it all kicks off right here with wood. For thousands upon thousands of years, wood was basically our #1 engineering partner. It's this amazing natural material that we figured out how to shape, how to build with, and we relied on it for just about everything, from our homes to our tools. Okay, but here's the thing. Not all wood is created equal. It's pretty much broken down into two main camps. You've got your softwoods and your hardwoods. And the difference between them is actually super simple. Your softwoods, think pine, cedar, they come from conifers, the trees with the needles and cones. And hardwoods, they come from deciduous trees, the ones that have leaves and drop seeds. Yep, it's really that straightforward.
But, of course, we couldn't just leave it at that. Our human ingenuity had to kick in. And that's where engineered woods come into play. See, you don't find these just growing in a forest. We make them. They're these composite boards, a lot of times made from leftover scraps and waste wood from sawmills. How clever is that? It's just a brilliant example of us taking a natural resource and kind of upgrading it. We manufactured it to have these very specific, often better qualities. So we weren't just using wood anymore, we were actively redesigning it.
So that's where our story takes a really interesting turn. We go from just shaping what nature gave us to fundamentally altering it. And that brings us to ceramics. Now, when I say ceramic, I bet you're thinking of a coffee mug or a dinner plate, right? And you're not wrong, but think bigger. Think about the moment we figured out how to use intense heat and chemistry to forge brand new materials with totally incredible properties.
Generally speaking, ceramic products fall into three main buckets. First, you've got whiteware. And yep, that's exactly what it sounds like. Your dinner plates, mugs, that sort of thing. Then you've got refractory products. These are the tough guys, designed to take insane amounts of heat. Think the inside lining of a furnace. And then there are engineering ceramics. This is where it gets really high-tech. We're talking aerospace, electronics, even medicine.
And the sheer versatility here is, well, it's just astounding. We use this stuff for everything, from simple clay bricks for building a house, all the way to industrial abrasives and super advanced engineering parts. We're talking about things like engine rotors and cutting-edge sensors. Just think about that. The same basic ingredients, just processed in a different way, can build a wall or help send a rocket to space. That right there is the power of ceramics.
Okay, now we get to the truly mind-bending part of this whole journey. So we've gone from shaping wood to firing clay, but what if a material could actually respond all by itself? Well, welcome to the incredible world of smart materials. You might also hear them called responsive materials, and you're about to see why.
Get this. Imagine a material that has a memory. That's not science fiction. That's a shape memory alloy, or SMA for short. It's this special kind of metal alloy that you can totally deform, bend it, twist it, whatever. But as soon as you add a little heat, it just snaps right back to its original shape. The possibilities here are just wow. We're talking self-repairing parts, medical stents inside the human body. Absolutely incredible.
Then you've got materials that can just change their fundamental properties. It's wild. Take quantum tunneling composite. In its normal state, it's an insulator. Electricity can't pass through it. But the second you squeeze it, bam, it becomes a conductor. And the harder you squeeze, the better it conducts electricity. This opens up a whole new world for things like touch-sensitive controls and even smart fabrics.
And if that wasn't enough, some materials can even generate their own power. Seriously, let's talk about piezoelectric crystals. So when you apply force, pressure, to a crystal like quartz, it actually generates a voltage. It is literally turning physical force into electricity. And this isn't some far-off futuristic idea, it's the tech inside the little clicker on your gas grill that makes the spark. You press it, it makes power. So cool. So all of this brings us to the really big question, doesn't it? We've gone on this incredible journey from simple wood to materials that can remember things, sense pressure, and even create their own power. We've seen how much our understanding has grown. So what's next? What are these new building blocks going to let us create in the future?
Just think about that for a second. For our entire history, it's been about us forcing our will onto this stuff around us, right? We carve it, we melt it, we mold it. But the future seems to be about creating materials that almost have a will of their own. We're going from a world that we shape to a world that can begin to shape itself. And that changes absolutely everything.